To AP Precalculus Practice Test Unit 2. Boom! It's the remix. If an arithmetic sequence has a first term of 6 and a common difference of -8, what is the 15th term? Well, let's whip out the arithmetic sequence formula. A sub n, which means the nth term, is going to equal a sub 1, which means the first term, plus n, which is the same n that we talked about a second ago, minus 1 times d, the common difference. All we have to do here is basically label stuff and plug stuff in. The first term, a sub 1, 6. Common difference, d, -8. Since we care about the 15th term, you're going to be n. So if we want to find the 15th term, we're going to do a sub 15 equals a sub 1, the first term, plus n, which we already called 15, minus 1 times d, which we called -8. Now it's just PEMDAS. 6 plus 14 times -8 is going to be 6 minus 112. And 6 minus 112 is going to be -106. With a negative living inside the 1. So let's scooch that out so it doesn't look like that. Now see, problem solved. Now I have this weird dot here. Let's get rid of that. You know what? I quit. The answer is going to be B. Thanks for watching. Love you. I hope you enjoyed my song. The fourth term of a geometric sequence is 45 and the fifth term is 90. What is the ninth term of the geometric sequence? Well, boys and girls, the equation for a geometric sequence is g sub n equals g sub 1 times r to the n minus 1. G sub 1 is the first term. R is the common ratio, what you multiply to get from one number to the next. N is the term you're talking about, so G sub n is that term. I do know that the fourth term, G sub n, is 45, which means n is 4. And I do know that in order to get from 45 to 90, you multiply 2. So to get from the fourth term to the fifth term, you multiply 2. That's going to be r. So let's use that information to get my first term of this geometric sequence. So g sub n, which is 45, so let me just jump right into it and say 45 is equal to the first term times the common ratio of 2 to the 4 minus 1, because it's the fourth term that we're talking about. So 45 is equal to g sub 1 times 2 to the third power. Or 45 is equal to g sub 1 times 8. Now let's divide both sides by 8, and that's going to give us our first term of 45 over 8. Now let's take that information and plug it back into our geometric sequence equation to find the ninth term. So g sub 9 is going to equal g sub 1, which we just found out to be 45 over 8, times the common ratio, which is 2, to the, what do we need, the ninth term, so 9 minus 1 power. So g sub 9 is going to equal 45 over 8 times 2 to the 8th. G sub 9 is going to equal 45 over 8 times 256. Now, through the power of math magic, I know very well that g sub 9 is going to equal 1,440, which is going to be C. So that's how you do that geometric sequence problem right there. The general term of a sequence is given by a sub n equals 70 plus 5 times the quantity n minus 8, where a sub 0 is the initial value. Who cares? Which of the following expression also gives the general term of the sequence? So, I don't know. Let's do a little bit of distributive, a little bit of combining like terms and see what happens. We get 70 plus 5 times n minus 8. All I'm doing is just rewriting the original equation without the a sub n part. Let's distribute 5, so 70 plus 5n minus 40. Let's combine like terms, so 70 minus 40 is going to be 30, and I get 5n plus 30, or in this case, 30 plus 5n, because they're giving us the old switcherooski, and that's going to give me the answer of B. So yeah, not a difficult problem, not by any stretch. Which of the following includes the input-output pairs 3, 5, and 4, 9? So eeny, meeny, miny, mo, let's test out C just for funsies. Let's test out C just for funsies. We're going to plug these points in and see what we get. Okay, so you would be my output, you would basically be my y, and you would be my input, basically my x. So if I were to plug in 3 for n, that would be 2 to the third plus 1, and I should get 5. So 2 to the third is going to be 8 plus 1, and last time I checked, 5 ain't 9. Now I've heard of working from 9 to 5, but 5 isn't 9. So it's not C. How about we try A? I don't know. Let's try A. You would be my y, you would be my x. So if I tried 3 and plugged in 3, I should get 5. So 5 should be equal to negative 3 plus 3 minus 1 times the quantity 4. 5 should equal negative 3 plus 2 times 4. 5 should equal negative 3 plus 8. 5 should equal 5. Yes, sir. Now, that's 1 point. So to test the other one, we are going to plug in 9 equals negative 3 plus 4 minus 1 times 4, which means negative 3 plus 3 times 4 has got to be equal to 9, and negative 3 plus 12 has got to be equal to 9, and you know what? 9 is 9, so A is our guy. A sports team needs to buy 1 ball and between 1 and 5 jerseys, inclusive, for their upcoming game. The cost of the ball is B dollars and the cost of 1 jersey is J dollars. So the output values of which of the following give the possible cost for these items in dollars. Note, assume any taxes are included in the cost. So here's our option. Our option is we can buy 1 ball and 1 ball only, or we can buy 1 jersey, 2 jerseys, 3 jerseys, 4 jerseys, or 5 jerseys. Now, that gives us 2 possible options, and B and D just ain't it. Now, you might be looking at A and C and say, these are the same thing, but technically, if it's linear, we could say something to the effect of, like, X is how many jerseys we can buy, and in this case is how many jerseys we can buy. If it's linear, technically a linear function allows for decimals. Whereas an arithmetic sequence is talking about the number term of a sequence. You wouldn't say, hey, let's focus on that 1.5 term. No, you would only focus on the first term, second term, third term, fourth term, fifth term. So we are going to go with C here, because when you deal with arithmetic sequences, you only care about integer terms. And in this case, if we're buying jerseys, we only care about integer jerseys. Linear function allows for decimals and stuff like that. So in this case, even though A looks like it would be a legitimate option, it's not in this case. So we're going with C. The value 3 times 3 times 3 times 3 times 3 times 5.6 is the output value of an exponential function of the form f of x equals a times b to the x, where a and b are constants. So let's set this up. We have f of x equals 3 times 3 times 3 times 3 times 3, so that's 5 of them, and our initial value is going to be 5.6. All right, so there's our equation, bada bing. Which of the following describes a function and input value that corresponds to the output value? Well, these are all exponential functions. It has an initial value of 5.6, so that's not going to be u, and that's not going to be u, so let's focus on C and D. A has a base of 3, and a base of 3, so that allows for that. That's still good. And an input value of 5.6. Well, by input value, what that means is we're assuming that the input value is x, and we're inputting 5 in this case because there's 5 threes. So the answer in this problem is going to be D. It wouldn't make sense to have 5.6 again in this problem. So even if you're looking at this and you're like, I'm not 100% what input value means in this case, we could still realize that we wouldn't use 5.6 twice if it's not seen twice. So we're going with D. D seems to make sense, and that's our answer. An exponential function f is defined by f of x equals a times b to the x, where a and b are positive constants. The table gives values of f of x as selected values of x. So whenever we're building ourselves an exponential function, all right, we have a times b to the x. A is going to be your initial value when x equals 0. Why is that? Well, when x equals 0, it doesn't matter what b is, you get 1, and so a times 1 is going to be my guy. So of course x has got to be 0 in this case. Now when x is 0, I get 40. So 40 is going to be my a. Now b is basically common ratio. In other words, what you do to get from one term to the next. In this case, the way we get from 40 to 20 to 10 to 5 to 5 over 2 is we divide by 2, or better yet, multiply by a half. So b is going to be 1/2. So we can set up our equation as f of x equals 40 times 1/2 to the x power. So a is 40, b is a half, and that gives us b as our answer. So it's exponential decay, and by the way, decay is whenever your b is a number in between 0 and 1, our numbers go down. Growth is if our b is bigger than 1. And in this case, since b is a half in between 0 and 1, it's exponential decay. So a lot of stuff going on there, but we answered b, and b is our answer because we answered b. And b is our answer. Thanks for watching. The function f of x equals 36 to the negative 2x can also be written as which of these guys? So let's see if we can break this down and simplify it as much as humanly possible. So we have 36 to the negative 2x. 36 is a square. More specifically, it's 6 squared. So we're going to rewrite this as 6 squared to the negative 2x. Now, whenever you have a power to an exponent, you multiply exponents. So this becomes 6 to the negative 4x. Now, whenever you have a negative exponent, you take that and drop it down to the bottom of a fraction and make it a positive exponent. So I end up in this case, there's not much I can do after this. I end up with 1 over 6 to the 4x power, which seems to match up with b. And that's our guy. The function g of x equals 25 to the x over 2 can be written as, well, let's take this and mess around with it a little bit. So we have 25 to the x over 2. Okay, first things first, 25 can be written as 5 squared. And that's to the x over 2. Whenever you have a power taken to another exponent, you multiply exponents. 2 times x over 2 allows the 2's to cross out, leaving us with just 5 to the x, which gives us d. Let h of x equals 9 times 2 to the negative x over 2, find h of 1. Well, if h of x equals 9 times 2 to the negative x over 2, then h of 1 is going to be 9 times 2 to the negative 1 over 2. So that 9 stays a 9. Negative exponent means you move it to the other side of a fraction bar and make it positive. So like that. When you take something to the 1/2 power, that's the same exact thing as taking the square root of it. So I have 1 over the square root of 2, and 9 times 1 over the square root of 2 is 9 over the square root of 2, which matches up with b, baby. The function f is given by f of x equals 3 to the x, and the function g is given by g of x, which is f of x over 9. For which of the following transformations is the graph of g the image of the graph of f? Well, g of x is going to have me take f of x, which is 3 to the x, and divide it by 9. Now I should be able to look at 9 and say, well, wait a minute. 9 is the same thing as 3 squared. When you have terms of the same base and you're dividing them, you subtract the exponents. So we can rewrite this as 3 to the x minus 2. Now, with x, we are subtracting 2. What this is a horizontal translation, which means you move left or right. Since this is minus 2, the devil's going to tell you to move left too, but remember, when things are coupled with x, it's the opposite of what it appears. So this guy is actually going to be right 2. So this is going to be a horizontal translation to the right 2 units. The following table shows values of the exponential function f of x equals a to the bx, where your x values are 1, 2, and 3, and your f of x's are 6, 8, and 54. Based on this model, what is the predicted value for f of 5? Now, if we're going to set something up that's in the form a times b to the x, your a is going to be whatever your initial value is when x equals 0. Your b is going to be my common ratio, whatever it is that I do to get from one number to the next. Issue number 1 is I don't know what happens when x is 0. But what I do know is to get from 6 to 18 and from 18 to 54, I multiply 3 each time. So what I can do is if I'm right here at 1, if I want to find out what 0 is, work backwards and divide by 3. And when I divide by 3, I get 2. So 2 is going to be my A, and 3 is going to be my B. That allows me to build the formula f of x equals 2 times 3 to the x power. Now, using that information, I can find out what f of 5 is. So, f of 5 is going to be 2 times 3 to the 5th power. 3 to the 5th power is 243. So, 2 times 243 is going to be 486. 486, which matches up with B, baby. The half-life of a certain radioactive substance is 5.3 years. You start out with 350 grams of the substance. How much of the substance will remain after 16 years? Well, the half-life formula is going to be y equals an initial amount. So a sub 0 is going to be your initial amount, okay, times 1/2 to the t, which is time and whatever it is that we're dealing with, over h, which is half-life. Now let's label what we know. Okay, the half-life, our h, is going to be 5.3. Our initial amount is going to be 350, and the time that we're talking about is going to be 16 years. So years matches up with years, no trickery. We could just take this guy and throw it straight into our calculator. So y equals 350 times 1/2 to the t, which is 16 over h, which is 5.3. So let's run to our calculator, type that in, and see what we get. All right, so to do this problem, it's just a matter of typing stuff out. 350 times 1/2, so 1 divided by 2, to the, and the nice thing about these guys is you can just plug everything straight into your calculator. 16 divided by 5.3, hit enter, and you get 50 or 43 point, and we'll round that up to 182. So let's go back and circle that option. And we ended up with y equals 43.182. Ooh, don't blink on that one. Blink 182, get it? It's a band from my youth, one of my favorite bands, and anyway, the answer is C. Thanks for watching. A startup company's revenue is modeled by an exponential function. The company's revenue is recorded as follows. We've got time as 0, 5, and 10. We've got revenue in millions, by the way, so we'll have to deal with that when we have to deal with that. 1.5, 4.5, 13.5. Based on this model, what is the predicted revenue after 20 months? We have a calculator problem. And since it's an exponential function, what we're going to do is use what's called exponential regression, or what appears in your TI-84 Plus as expreg. So let's go to our calculator, plug a bunch of things in, and see what we come up with. All right, so in order to do exponential regression, we're going to start off by hitting Stat and edit some values into the edit portion of Stat. So our x values are going to be the time in months, so that's 0, 5, 10, like so. Our revenue is going to be 1.5, 4.5, and 13.5. So this is me typing those numbers out. Now, we're going to need to use this equation to predict 20 months. Right? So if I'm going to do that, I'm going to hit Stat. I need to come up with my equation first. And I need to do Stat and go all the way down to exponential regression, expreg, which is 0. Now, since I'm going to use this equation for later, what I'm going to do is I'm going to go down to store reg EQ, hit vars, go right to yvars, and hit enter, enter. So now I can store this into my y equals portion. So I go to calculate, I hit enter, I get that function right there, which I'm not going to bother writing down because I don't need to. It's there for me. Okay, so if I want to find out what happens at month 20, what I can do is I can go to second, table, scroll all the way down to 20, and find out that 20 is 121.5. So let's go back to our options and circle 121.5. So when all was said and done, we ended up with C, which is $121.5 million. And that's our answer. A statistician recorded the pregnancy rate per 1,000 U.S. women aged 15 to 19. Oh boy, I don't like this at all. From 1990 to 2002, a linear regression was used to develop a linear model for the pregnancy rate over time. The figure shows a graph of the residuals of the linear regression. Which of the following statements about the linear model is true? Now, this is a residual plot. And whenever you have a residual plot, the residual plot is basically the result of you coming up with a line of best fit and having dots above and dots below and dots above again. Now, this guy is just a very, very, very terrible looking rough sketch of what we have over here. Now, if we saw a bunch of dots on a scatter plot that looked kind of like this, and we drew a line in between them, most people would look at that and be like, yeah, I'm not super happy with the line, but I guess that line does fit the data. Well, that's what we're doing here. A residual plot fits the data if there's no pattern whatsoever to my dots. You have a bunch of dots up here, you have a bunch of dots down there. I don't see a pattern at all. So this linear model is appropriate because it fits the data. So the linear model is appropriate, the linear model is appropriate, C and D are not going to be the option. Now, why is the linear model appropriate? Because the residual plot shows a clear pattern? No, it's because the residual plot does not show a pattern. Okay, now what they mean by shows a clear pattern is maybe you have a residual plot and the dots go up and down like that. That would be a clear pattern. With this guy, we just have dots scattered above and below, and there's really nothing that's there to it. It's just that line kind of goes in between, and therefore the residual plot seems to work and the linear model is appropriate. Fun stuff. Let f of x equals x plus 2 and g of x represent the graph of some unknown function. Consider the composition function g of f of x. All right, well, g of f of x would be me replacing f of x with x plus 2. So I now have g of x plus 2. Neat. Which of the following describes the transformation of the graph of g in g of f of x? Well, if this is a transformation, I just went from f of x, which looks like u, to x plus 2. And if I ever add a number inside the parentheses with x, that is a horizontal transformation or a horizontal translation. And I'm going to move either left or right. Now, since this is plus 2, it's the opposite when it lives with x, which means it's not going to be right 2, it's going to be left 2. So this is a horizontal translation to the left 2, which means the graph of g of x is shifted 2 units left. So the answer is going to be B for this one. Let f of x equals 3x minus 1 and g of x equals x squared plus 4. What is g of f of x? Well, we'll write this out as g of f of x. F of x is 3x minus 1. So I need to find out g of 3x minus 1. So I'm going to rewrite g, and I'm going to replace every x with 3x minus 1. So 3x minus 1 squared plus 4. Now this is a perfect square trinomial, so if you need to write this out like this, go ahead and write this out like this and FOIL it out. When doing that, you get 3 times x times 3 times x, which is 9x squared. Minus 3x is minus 6x, and negative 1 times negative 1 is positive 1. So you could have gone right from here to here, but I wanted to remind you why this happens by doing that little extra step. It only took me an extra 30 seconds, no big deal. But at the very end of it, I add 4. These two guys combine, and those are the only things that do combine, and so I get 9x squared minus 6x plus 5, which is going to be A. And that's it, we're done. Given the table of values for the functions of f of x and g of x, we have x's and f of x's and g of x's and stuff. What is g of f of 1? All right, well, g of f of 1 is going to be me first finding out what f of 1 is. So let's go to where x equals 1, and f of x when x equals 1 is negative 1. So now what I have to do is find out g of negative 1. So I go back to this table, I go to where x is negative 1, and when x is negative 1, g is regular 1. So at the end of the day, g of f of 1 equals 1. So my answer is C. The function f of x equals x squared minus 5 is defined for the negative 3 is going to be less than x, is going to be less than negative 1. So you live on the interval negative 3 to negative 1. Now, just for funsies, right? This is what it's going to look like. X squared minus 5 is going to live down here. Okay? We only care about the part that lives in between here and here. So, I don't know, like here and here we'll say. We only care about that part. All right, now, which means whenever I figure out the next thing, which is which one of these defines the inverse for which values, I'm flipping this and reflecting it along the side. So what's going to happen is this guy is going to be a mirror image that's going to look like this. Okay, so I'm dealing with that. I'm dealing with that. Now, that doesn't really matter. What matters is, first things first, I'm told that x has to be in between -3 and -1. So let's go to f of x and see what happens at -3 and see what happens at -1. So f of -3 is going to be -3 squared minus 5. -3 squared is 9. 9 minus 5 is 4. So f of -3 is 4. That gives us a point on the f of x function of -3, positive 4. I'll explain why that matters in a little bit. Now, f of -1 is going to be -1 squared minus 5, which is 1 minus 5, which is -4. So that gives us the point -1, -4 on f of x. Now, that is going to help me answer this part of the problem. I still need to answer this part of the problem. So this part of the problem has me finding the inverse of f of x. So to find the inverse of f of x, I don't like looking at f of x. I like to call it y. So step number 1 for me is always replace the f of x with y because it just looks prettier. Step number 2 is going to be swap the x and the y. So you are now x equals y squared minus 5. Now we solve for the new y. So we add 5, x plus 5 is x plus 5, they don't combine, and you end up equaling y squared. Now in order to get y all by itself, you square root both sides. That allows you to cancel out. If you square root both sides to solve, you have to attach the positive or negative. So that leaves us with y equals positive or negative x plus 5, and we can finally put this back into its f of x form and say the f inverse of x is equal to positive or negative x plus 5. Here's the issue. We care about the negative x values, which means we're not going to care about both positive or negative square root of x plus 5. Since we were dealing with the negative side, our inverse is only going to care about the negative side as well. So that's going to be our equation. That's the inverse. Now we care about the x values for the inverse. If f gave you these points, then f prime is going to be the flip-flop version of these points. So the flip-flop version of these points are going to be -3, 4, nope, 4, -3. And -1, -4, nope, -4, -1. Flip-flop the x and the y. That's why we swap x and y at the very beginning. Now, if I care about the x values, I care about magic happening between -4 and positive 4. So all the fun stuff is going to happen between -4 is less than x is less than regular 4. So my final answer is going to be f inverse of x equals negative square root of x plus 5, and that's going to be valid for all x values between -4 and positive 4. The answer is A. The function f is defined by f of x equals 3x minus 4 all divided by 2. Which of the following equations defines the inverse? All right, well, in order for me to find the inverse, I like to replace f of x with y and say y equals 3x minus 4 all over 2. The next step to find the inverse is swap the x and the y. So you are now x equals 3y minus 4 all over 2. Now what we do is we solve for the new y. So let's multiply both sides by 2. Multiply both sides by 2. Cross you out. That gets you 2x equals 3y minus 4. The next step in solving for the new y is to add 4 to both sides. 2x plus 4 don't combine, so you get 2x plus 4 equals 3y. Finally, to do the math portion, you divide everything by 3, divide it all by 3, and you end up with y equals 2x plus 4 all over 3. So now that we have y all by itself, we can go back to its original form and say this is the inverse. So f inverse of x is 2x plus 4 all over 3, which is going to be a. And that's how you do it. Consider the function f of x equals the square root of x minus 2. What are the domain and range of the inverse function f inverse of x? So in order to do that, we need to find the domain and the range of regular f of x. Now, the graph of the square root of x looks like this, which means the graph of the square root of x minus 2, since the negative 2 lives with the x, is going to be a translation to the right 2 units. So the domain of this guy, of f of x, is going to be from 2 all the way on forever. So we'll say the domain is including 2 all the way to infinity. The range is going to be starting at the x-axis, because you're allowed to get 0 for an answer, so 0, and all the way up to positive infinity, like so. Now that's f of x. To find the domain of the inverse and the range of the inverse is very, very, very simple. Just flip-flop everything. So f inverse of x means the domain is now the range and the range is now the domain. So the domain is now 0 to infinity, and the range is now 2 to infinity. And by doing that, we end up with C. I had to figure it out for a second there. But that's how it's done. Easy peasy. Consider the following table of values for the functions of f and g and their inverses f inverse and g inverse. Based on the table above, which of the following statements are true, select all that applies. So they want us to find out what f of x is, and then as a result find out what their inverses are. So let's take a look and see if we can find any patterns for f of x. Now as x goes up by 1, f of x goes up by 2. Which means this is linear. So f of x is a linear function that goes up by 2. All right, so if my x value is at 1 and begins at 3, that means if I were to go up to an invisible 0, 3 would go down to an invisible 1, so my y-intercept would be 1. So f of x is 2x plus 1. Looks like g of x is going to follow the same trends for the most part. So if I were to take a look at this, this goes up by 2 also every single time. So g of x equals 2x. And if you go up by 2, then going backwards 1 is going to be invisible 3. So we're going to say plus 3 for that. So f of x is 2x plus 1, so check and check, that doesn't help. And g of x is 2x plus 3, so check and get rid of u. Okay, so now use that information to find out what f inverse of x is and g inverse of x is. So I'm going to do that by replacing, for f of x first, y with f of x, so y equals 2x plus 1. Now swap the x and the y to make it x equals 2y plus 1. Solve for your new y. Subtract 1, you get x minus 1 equals 2y. Divide by 2, and y is going to equal x minus 1 all over 2. Now this was f of x. So now we know that f inverse of x is x minus 1 all over 2. Let's do the same thing with g of x. By the way, does that allow us to eliminate anything? X minus 1 over 2, x minus 1. Yep, so C is not an option, D was not an option. All right. So A is still a possibility, it looks like. Let's do g of x and do the same thing. Okay, turn g of x into y. Y equals 2x plus 3. swap the x and the y, so x equals 2y plus 3 minus 3 minus 3 gives you x minus 3 equals 2y. Divide everything by 2. And now y equals x minus 3 all over 2. So that was g of x. So now we can say that the inverse of g of x is going to be x minus 3 all over 2. So this is, I didn't even realize that. This is the circle all that apply. So we found out that f of x is 2x plus 1, check, and f inverse is x minus 1 over 2, check, a is a possibility. And we found out that g of x is 2x plus 3, check, and g inverse is x minus 3 over 2, check, b is the other possibility. So a and b are our answers. RR is what pirates say when they like and subscribe. What is log base 3 of 81? All right, well, log base 3 of 81, I'm going to write out like this. Log base 3 of 81 equals x. Now, if I give you something in the form of log base b of y equals x, I can write that out as b to the x equals y. This is me transforming a logarithmic equation into an exponential equation. You would be my b, you would be my y, you would be my x, which means I can rewrite this guy as 3 to the x equals 81. Now what does that do for me? I can rewrite 81 as 3 to the 4th power. So 3 to the x equals 3 to the 4 means since they have the same base and they equal each other, I can say that x equals 4. Which means log base 3 of 81 is just 4. And that's it, we're done. Solve for x, we've got log base 2 of x minus log base 2 of 8 equals 3. Using our rules for logarithms, if we subtract two logs of the same base, that means we divide the insides in order. So this becomes log base 2 of x over 8 equals 3. Now, this is what I'm going to do. Whenever I'm trying to solve an equation and I notice a log there, I can get rid of the log by taking 2 to the of both sides. Whatever the base is, I turn these guys into exponents and I use that base as a new base for an entire power. Now, 2 to the log base 2 of stuff allows the 2 and the log base 2 to cancel out, and I could just drop down whatever's left in that parentheses. That's going to equal 2 to the 3rd power, which is 8. Now it's just a matter of me solving for x by multiplying both sides by 8, and 8 times 8 is 64. So my answer is B. The function g of x is defined by g of x equals log base 5 of log base 4 of x. Which of the following is an expression for the inverse? Now let's deal with that in a minute. First off, I have to handle this monstrosity. So I'm going to call g of x y since I'm going to end up dealing with the inverse anyway. And I have log base 5 of log base 4 of x. Close it, close it. Now I need to get rid of both of these logs. The way that I can get rid of a log is I notice the base and pretend both of these guys are exponents and take that base to these powers. What that allows me to do is 5, log base 5, cancels out. On the left I have 5 to the y, and on the right these are gone and I drop down log base 4 of x. And you might be thinking, well, hold on. We have log base 4. Can I just do the same exact thing? Yup. If I have log base 4 in the way, by pretending you're an exponent, I could take 4 to the log base 4 and that'll cross out. Now I have to do the same thing over here. So now on the left I have 4 to the 5th to the y equals, well, just x. Now this is g of x. This is g of x. They want me to find the inverse. And in order to find the inverse, your first step is going to be swap the x and the y. So 4 to the 5 to the x is going to equal y. So the inverse of g is 4 to the 5 to the x, which is b. Very strange problem, but I like it. The function f is given by f of x equals 3 log base 4 of x. Which of the following describes f? They want to talk about whether it's increasing and whether it's increasing or decreasing at an increasing rate. So we're talking about concavity. We're talking about whether it's going up and to the right or down and to the right. So a log, traditionally, whether it's log base 4, log base 10, log base e, a log is going to look like this. By multiplying it by 3, all I'm doing is making it taller. So all I'm doing would be making it look like that. So it's the same type of behavior. So what it appears that it looks like is it appears that it's going up and to the right and it's concave down. Now that would mean increasing function. So f is an increasing function, f is an increasing function, f is a decreasing function, nope, f is a decreasing function, nope. Now if it's concave down, that means it increases at a decreasing rate. Concave down means the slope is decreasing, so it's increasing at a decreasing rate, which would get rid of u and leave me with b as my only option. So that's what you get for this one. A logarithmic function f is defined by f of x equals negative ln of x plus 4 on the domain between 0 and 5. Which of the following is true about f? Well, let's take a look at regular old ln. Regular old ln is logarithmic, which looks like this. Now, with this particular function, I'm doing two things. By multiplying it by a negative, by multiplying the ln by a negative, I am reflecting it over the x-axis. Okay, so I'm reflecting it over the x-axis. So let me do that. Let me draw a brand new guy. So now you are going to be spun upside down. Like that. Now the other thing that's going to happen is we add 4. That's a vertical translation, means we move up 4. So if we move up 4, this guy is going to be just like this. Okay? So I'm trying to get the arrowhead there. There we go. So it's going to look like that, give or take. So what do we have here? Well, we're not done yet. My domain is going to be between 0 and 5, which means we start here. Now here's the thing. I'm not allowed to take the ln of 0. That doesn't exist. Also, I'm not allowed to take the ln of a negative. So this is basically going to be a vertical asymptote for ln. The y-axis is going to be a vertical asymptote. So I can't plug in 0. And this guy is going to go up there forever for infinity. So the questions that are being asked is about its maximum or minimum values. This guy does not have a maximum value because it'll keep going up forever. So there's going to be no max. Now, if I cap this off at 5, it's going to bottom out right here, or wherever that's going to look like on the problem. I don't know how accurate this picture is. I just moved it up 4. But it's going to bottom out somewhere. So it will have a min. So it's not going to have a max, and it will have a min. And if that's the case, it's not going to have both. It will have a maximum. Nope. It will have a minimum, but no maximum. Yep, my answer is C. And D says neither. That's not the case. So I will have a minimum because of the fact that it stops at 5, and it won't have a maximum because this will keep going up forever right before it hits 0. The function f is given by f of x equals log base 3 of x. Which of the following is equivalent to f of 9? In other words, log base 3 of 9. Now it looks like what they want me to do is they want me to do the change of base formula. Okay, so very simply put, the change of base formula, if I have log base b of m, the change of base formula says that I can pick any value I want for the new log base. So log base k. Okay, and I'm going to make it into a fraction. Log base k over log base k. We're going to put m on top and b on the bottom. So what this would look like is this would be log base whatever number of 9 on top over log base whatever of 3 on the bottom. Now, that's definitely not going to be u. This has 3 on top, not going to be u. This has some weird 10 that shows up, and this has 9 on top and 3 on the bottom. Now, the k that they chose was 9. It doesn't matter what you choose, as long as it's the same number. So if I wanted to, yeah, I could say log base 9 of 9 over log base 9 of 3, and d is going to be a possible answer using the change of base formula. The function g is given by g of x equals log base 5 of x, and the function h is given by h of x equals log base 25 of x. Which of the following describes the relationship between g and h? Now, probably the best way of doing this is maybe setting both of these up as its own special version of like, whatchamacallit, the change of base formula, where I would take u, all right, and just go with me here. It's just, I mean, there's other ways that you could do this, but maybe once I do this, you would look at this type of problem and be like, oh, okay, I get it. So I know how to do one like this from here on out. Again, just go with me here. If I were to use the change of base formula, but use instead of base 10 or ln base 5, I would say that g of x can also be written out as log base 5 of x over log base 5 of 5. And what that does is that gets me log base 5 of x over 1. No big deal. Which, you know, common sense. Come on, what are we doing here? But again, go with me here, and maybe by doing it this way, it helps us understand what answers like this from here on out will be. H of x, if I continue with the log base 5 trend, would be log base 5 of x over log base 5 of 25. Now, log base 5 of 25 is log base 5 of 5 squared. Which means if I bring the 2 down, like this, that becomes log base 5 of x, bring the 2 out, 2 times log base 5 of 5 becomes 1. So you cross out. So we get log base 5 of x over 2, which is half of log base 5 of x. So while g of x was log base 5 of x, h of x is half of that. Huh? Right? So what we could say is h of x is half of g of x. So for equal input values, the output value of h is half the input value of g. So right away we can go with the answer of A. So yeah, definitely a strange type of problem, and it doesn't seem that way but 25 is bigger than 5. It seems a bit confusing, but that's what you would get after you plug stuff in. You actually get half the input value. So, weird, but that's how you do it. Simplify the expression ln of x plus 3 plus ln of y minus 3 minus 2 ln of z minus 1. Remember, ln is just a fancy type of log. Ln of x is the same thing as log base e of x, which means ln follows all of the same rules as log base e. So you would look at these guys first and notice that these ln's are being added to each other. So you multiply the insides. ln of x plus 3 times x minus y minus 3 is going to be x plus 3 y minus 3, bada bing. Now you still have minus 2 ln of z minus 1. What I could do is leave that as is and bring that 2 up there. So you have ln of x plus 3 y minus 3 minus ln of z minus 1 squared. When you subtract ln's, you divide the inside. So finally, our answer is going to be ln. You become an entire numerator, x plus 3, y minus 3, over z minus 1 squared. And that guy's going to be A. Expand the expression log base 2 of x cubed over yz to the 6th power. Now we're working backwards. Rather than moving things into a single logarithm, we're ripping things apart. So what you really want to do is rip them apart from the division part first. Whenever you're dividing inside a log, it's because you subtracted the logs in the first place. So step number 1 is to say, all right, well, log base 2 of whatever the numerator is minus log base 2 of whatever the denominator is. Now, what we could do is we could focus on exponents here and then something else here, but let's not kill two birds with one stone. Let's just take it one step at a time. We're going to leave this as log base 2 of x cubed for now, knowing that something's going to change later. All right. Whenever you're adding, or rather multiplying on the inside of logs, it's because you must have added in the first place. So me misspeaking there was kind of like me thinking ahead. All right. If I'm multiplying y to z squared to the 6th, inside the parentheses, it's because I added them in the first place. So log base 2 of y plus log base 2 of z to the 6th. So let's just quick distribute that negative real quick. And then we'll deal with exponents. Log base 2 of x cubed minus log base 2 of y minus log base 2 of z to the 6th. All I did was distribute the negative. Last step is any exponent living inside the parentheses, bring it out front. So finally we end up with 3 log base 2x minus, nothing happens here, log base 2y minus 6 log base 2z. And that's going to be A, baby. Let f of x equals 3 to the x minus 1 and g of x equals 9 to the x plus 4. Find x such that f of x equals g of x. Well, that's just fancy talk for let's set these guys equal to each other. So 3 to the 3x minus 1 equals 9 to the x plus 4. Now, whenever you see a power equals a power, you really want to see if there's a way you can make the bases the same. And you can with this one. 3 you can't do much with. You're done. But 9, I can write that out as 3 squared. So I have 3 squared to the x plus 4. Again, on the left, not much you can do. But on the right, when you have a power taken to another exponent, you multiply exponents. And when you multiply 2 to x plus 4, that's distributive property. So 3 to the 2x plus 8. Now that we have a 3 to the stuff equals 3 to the stuff, we could set the stuffs equal to each other, leaving us with 3x minus 1 equals 2x plus 8. And now it's just a regular old Algebra 1 problem where you have variables on both sides of the equal sign. Minus 2x, 3x minus 2x is 1x, x minus 1 equals 8, add 1, x equals 9 is my guy, which means B is my baby. Solve the inequality log of x minus 8 plus log of 2 is less than log of 3x plus 4. Whenever you see logs a part of every single term, that's a good thing. But what we need to do is we need to combine the logs as often or as much as we can on each side individually and then take it from there. A log of stuff plus a log of stuff means I multiply the insides. So you're going to have log of 2 times x minus 8. I know when I wrote that kind of backwardsy, but I like viewing distributive property in that way. That's going to be less than log of 3x plus 4. So let's quick distribute here. Bang, bang. Log of 2x minus 16 is going to be less than log of 3x plus 4. Now, a gentle reminder, log is the same as log base 10. I have log of stuff is less than log of stuff. How do I get rid of the logs? You can cross them out. You can just cross them out. But why can you just cross them out? Because if I were to make these both exponents and take 10 to the stuff and 10 to the stuff on both sides, the 10s and the logs cancel each other out because that's log base 10. And what you're left with is 2x minus 16 is less than 3x plus 4. And now it's just solving inequalities that you would have seen in the ugly parts of Algebra 1. Right? Subtract 3x from both sides. That gets you negative 1x minus 16 is less than 4. Add 16, and that gets you negative x is less than positive 20. Divide both sides by negative 1 in order to get rid of the negative. And whenever you divide an inequality by a negative number, you flip the sign. X is greater than negative 20 here, which is going to be A. So the problem looks bad, but really wasn't. It was fine. I lived. I survived. Ms. Rodriguez wants to save for a new luxury yacht. Good for you, Miss Rodriguez. You and me both. Need more subscribers, though. She currently has 80 grand in an account that pays interest continuously and will need 500 grand in total. If she leaves her money in the account for 10 years and does not add anything, what interest rate would she need to achieve her goal? Okay, use the equation below where A of t is the total amount of money, P is the principal starting value, R is the interest rate, and T is the time in years. So what we need to search for is some magical interest rate that's going to turn 80 grand into $500,000 in 10 years. Whatever bank this is, I want it. I want it. I'll tell you one thing, it's not Diamond Credit Union, that's for sure. All right, what do we know? Well, this is what we start out with. So that's going to be my P. Okay, 80 grand. U are going to be what we're saving up for, so $500,000. 10 years. R is what we don't know. And E is the letter E. The number E, technically. So we have 500,000. Right? Equals 80,000. E to the R times 10. Divide both sides by 80,000. Divide both sides by 80,000. And I believe that gives you 6.25 equals E to the 10R. Now, up until this point, we didn't need to rely on this. But now we do. So what we're going to do is we're going to... not yet. Let's ln both sides, because I forgot about that step. Ln both sides, cross u out. That leaves me with ln of 6.25 equals, drop down the 10r. Divide both sides by 10, and now we could just throw all this into our calculator in one step. So r is going to equal whatever ln of 6.25 over 10 is. All right, so let's run to our calculator, use our calculator to figure that out, come up with the best r that we can. All right, so just one thing that we have to do here is type in ln of 6.25. So where is it? There you is. ln of 6.25, and then taking whatever gross that number is number that is, gross, gross, whatever number gross that is, and dividing it by 10, and we get 0.1832, which I'll round up to 0.1833. And then we'll go back to the main problem and just do it, like Nike. And we ended up with R equals 0.1833. Now, what does that mean in percentage terms? Well, whenever you want to turn a regular decimal into a percent, you just multiply by 100 or move to the right 2 times. So in this case, moving to the right 2 times gives us a wonderful interest rate of 18.33%, which is extremely irrational and unreasonable. But maybe there exists a bank out there in heaven. Thanks for watching. In a semi-log plot, which of the following pairs of functions appear linear as parallel lines? Well, when you're looking at semi-log plots, what's going to happen is anything that's exponential, anything that's in the form a times b to the x will appear as straight lines. Again, anything that's exponential that has the same base is going to appear as a straight line. So anything that's not exponential is not going to appear as a straight line. It's going to be distorted. That's what semi-log plots do. Instead of going up by regular numbers, they go up by 10, and then all of a sudden you become 100, and then all of a sudden you become 1,000. So what's happening is the exponential stuff appears linear. The exponential stuff appears linear. So A gives me 2 linear functions, 3x and 3x plus 5. On a regular coordinate plane, those are going to be parallel, but this is not a regular coordinate plane. This isn't going to be parallel in any sense of the world because these are cubics, and what this does is just make this 4 times taller. So you're no good. Okay, now 5 to the x and 2 5 to the x are both exponential functions with the same base of 5. So it's going to be C. There's temptation to look at D and say, LNs, because there's semi-log plots, and a log plot is for LN. No, it's not going to be you. Okay, semi-log plots only do this for exponential functions, so C is going to be the answer that makes sense in this case. C and only C. Yes and only yes. Free response question number 1. We have ourselves this table of x values, f of x values, and g of x values, and we have to answer all of these composite and inverse and other crazy types of questions. G of f of 3 is going to ask us to find g of whatever f of 3 is. So to find out what f of 3 is, go to your table and find out where x is 3. And then find the number on the f of x line, and you'll find out that when x is 3, f of x is -1. So f of 3 is -1. Now that I have -1, I need to find g of -1. So we do the same thing, go to our table and go to where you have -1, and g of -1 is going to be 0. Okay? Not so bad, not so bad at all. The next one, I mean, that one was easy peasy lemon squeezy. This one is grossy, wossy, Nancy Pelosi. Oh, I wonder how she's doing. 2 times, I'm going to write this out as f of g of -1. Like that. Plus 4 of g of 0 minus 1. Let's start out by finding out g of -1. So let's go to -1. G of -1 is 0, which I just did. 2 times f of 0. Equals plus, not equals, plus 4 times g of 0, which is different, minus 1. So let's go to the zeros and find each one. Here's my 0. F of 0 is 5. 2 times 5. Plus 4 times g of 0 is 1. So 4 times 1 minus 1. 2 times 5 is 10. Okay. 4 times 1 is 4, minus 1 is going to be 14 minus 1, which is 13. So B becomes 13. So A was 0, B is 13. Not bad. This one's not so bad. You're going to do the same exact first step as we seem to have done already a couple times. F of 2 means let's go to the function, Go to the table. 2 matches up with 1. So the G inverse of f of 2 is G inverse of 1. Now, when you do the G inverse of 1, the devil's going to tell you, oh, yes, let's go to 1. But no, you resist the devil because remember, inverses are backwards. So you're swapping the x and the y. That's what you do. So instead of going to the 1 on the x, you go to the 1 on the g of x, which gives us 0. So it's backwards. And that's why I accidentally said 0. But that's free response question number 1. We did it. Free response question numero dos. The table on the right shows the population of a city in thousands. In thousands. So this actually means 1 million in the real world. You get the idea. What is an exponential model that fits the data? So this is exponential. And what we're going to have to do is we're going to use our calculator, our TI-84 Plus calculator, to do an exponential regression problem. So let's go off to the side. Let's do part A by using exponential regression. Now, before I do that, let's take a look at B. B and C are going to have us use that equation. So not only am I going to find the equation, I'm going to store the equation. So make sure you watch the video and see how I do both of those. All right, so if we're going to do exponential regression, we have to plug some points into our calculator. So let's go to Stat. Let's go to Edit. The left side is going to be 0 through 5, so that's a 1. Bad start by me. 0 through 5, like so. And then we just type in the numbers that we're given. Don't make a typo, otherwise everything's going to blow up. So this is me just making sure I don't make a mistake. This would be a good time for you to drop a comment, say how much you love me, how great I am, all of that stuff. What else can I tell you to do during this time? Like and subscribe, I guess. I don't know. Don't watch Khan Academy. I need an enemy. That's what I need. 1284.03. So I think I'm all right. I think I'm all good with all of these numbers. Just scrolling through, I don't see any glaring mistakes or mistakes at all. All right. So this is my information. Looking at B and C, not only am I going to find out part A, which is what's the equation, but B and C are going to be asking you to use that equation to get future info. So yes, I'm going to do the stat thing. Yes, I'm going to go to calc. Yes, I'm going to go down to 0, which is exponential regression. And yes, I'm going to hit enter. But before I hit calculate, I'm going to go down to store reg EQ and save this equation for later use. So the way I do that is, I go down to store reg EQ, I hit vars, go to y vars, enter, enter, and now when I calculate this guy, it's going to store it under y equals, which will help me with part B and part C. But first I need to come up with my equation, which is, you've got to be kidding me, almost 1,000, but 0.002 away. And yes, it's AP Precalc, and we have to round to 3 decimal places. So yeah, this will be 999.998 times 1.051 to the x. So I'm going to go off and write that out. So for part A, after all of that, we got this awfully close equation of y equals 999.998, that's a 9, times 1.051 to the x. Right? So there you have that. What will the population be after 50 years? Well, let's go to the calculator and see what happens when time is 50 and what number we get. Keeping in mind, this is in thousands, so I'm going to have to do a little converting. Now, part B here is asking me to find the population after 50 years. So this is what I'm going to do. I'm going to hit second. I'm going to hit table because it won't take me forever to scroll down to 50 if I just hold the button down like so. Like so. Now, the number that I see here is 12,182.674. Now, the original problem's in thousands, so I'm not going to write out 12,182.6 whatever. I'm going to make sure I convert that into thousand, which is thousands, because this is in thousands. So that's going to be 1 million or 12,182,000. blah, 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 blah. All right? So, yeah, that's how we do that guy right there. All right, so the number that I got was 12,182. Don't blink. Get it? 674. Now, turning that into thousands is me multiplying this by 1,000 or just moving my decimal place over, right, 3 times to get 12,182,674. 12,182,674. Okay? So that's going to be my population after 50 years. How long will it take for the population to reach 1.5 million? Well, that's 1,500, according to this chart. So, we're kind of along the way, but I want to use my calculator to find out when I will hit this 1,500 or 1.5 million mark. So let's go do that and see what happens. The last step is for me to find out how long it takes to get me to 1.5 million, which is 1,500. So that doesn't take too long in the initial process, I believe. Like, not long at all. At all. There we are. So somewhere around year 9. Right? 8.5-ish, year 9. But if I want to be really specific, this is what I need to do. I'm going to hit y equals, okay, there's the equation that I had before. I'm going to set this equal to 1,500, which represents 1.5 million. Okay, I'm going to hit graph and see absolutely nothing because those numbers are huge. So let's go back and remind ourselves, all right, well, if y is going to be 1,500, then what I really need to do is go to my window, and knowing that this is going to happen somewhere around the 8-9 area, I'm going to set my y minimum. Since I wanted 1,500, I'm going to set it to 1,400 with a max at 1,600. And so when I hit graph, I'm going to see that horizontal line right in the middle there. Okay, and so here it is later in the problem where they intersect. I need to find out exactly when they intersect so I can say 8 point whatever years. So I hit second, calc, intersect. Okay, I'm going to go right a bunch of times until it appears like at 8 point whatever. There we are. Okay, so I'm going to hit enter for the first curve. I'm going to go right a little bit, hit enter for the second curve, and guess, always hit enter, intersection of 8.109. So that's going to be my answer, 8.109 years. So somewhere in February, whatever. But we're just going to say 8.109. So the year we got was 8.109. So years, let's just make sure we say years, and that'll do it. So, yeah, that's exponential regression, boys and girls. Lots of fun, lots of fun, lots of fun. Let f of x equals 2 log base 2 of 3x plus log base 2 of 2x minus log base 2 of 6x. All of those logs. It's like we're building a cabin. And then we have just one down here, but a bunch of stuff happening on the inside. So what am I supposed to do? Condense f of x into a single logarithm. So I'm going to need some space, so I'm going to write this over here. The first thing that I want to do is take these 2's, right? Or just that 2. I was thinking maybe there would be more. Any coefficient that you see in a log, you're going to make an exponent. So step number 1 is going to turn that first term into log base 2 of 3x squared. We're not going to touch this guy yet. We're not going to touch this guy yet. And even in the next step, we're not going to touch either of them either. Because when I square a parentheses, I square both parts of that parentheses, not just like the x. So this actually becomes log base 2 of 3 squared, which is 9, x squared, plus log base 2 of 2x minus log base 2 of 6x. Whenever you add 2 logs of the same base, you multiply the insides. So this guy becomes log base 2 of 18, because 9 times 2, x squared times x is x cubed, and then I still have minus log base 2 of 6x lingering around. When you subtract logs of the same base, you divide the insides. So you become log base 2 of 16x cubed, 18x cubed over 6x. And that's going to simplify to 18 over 6 is 3, x cubed over x is x squared. So f of x, written as a single logarithm, is going to be log base 2 of 3x squared. Fun stuff. Now for part B, I'm going to do literally the opposite. I'm going to take something that's already put together and rip it apart. So let's take u, move it down here, right, and say log base 2 of 64x. Well, if I'm going to rip stuff apart, I'm probably going to do the opposite of me turning that coefficient into an exponent and me taking an exponent and turning into a coefficient. 64 is 2 to the 6th power, okay? And then I have x just kind of lingering there. All right, so what I'm going to do first is to separate these. I'm going to realize, well, if I'm multiplying 2 to the 6th and x, it's probably because I added previously. So you become log base 2 of 2 to the 6th plus log base 2 of x. Take that 6, bring it out, and now we end up with 6 log base 2 of 2. I know you're going to want to turn that into something, but don't. Plus log base 2 of x. So g of x, when ripped apart, is 6 log base 2 of 2 plus log base 2 of x. Now, what I want to do is find an x such that f of x equals g of x. Well, I want them all put together in order for me to do this. I want to use this version of part A, the one that's already condensed, and this version of part B. Because by setting these two equal to each other, I have a log base 2 of 3x squared equal to a log base 2 of, what was it, 64x. Okay. When you have a log base 2 equals log base 2, or a log of anything, as long as the same base equals a log of anything, you cancel each other out just like that. Here's why. If I were to take 2 and make that a base and make my logs an exponent, that cancels you out, leaving me with just 3x squared equals 64x. Now what I want to do is I want to subtract both sides by 64. So let's go and do just that. Let's go up here and show those steps. We've got 3x squared minus 64x equals 0. I can whip out an x, but that's it. 3x minus 64. Now, my zero product property says they're going to be 0. Here, if I'm going to do this, I have to do 3x minus 64 equals 0. To save some time, I'm going to add 64 to both sides. So that's going to equal 64. And I'm going to divide it by 3, and so x is going to equal 64 over 3. Now, here's where you have to be very, 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 very careful. Whenever you're solving a log and you get more than one answer, chances are one of those answers won't work. And why won't it work? Because it's going to have the log of a 0 or a log of a negative, both of which are illegal. You can't take the log of a 0 and you can't take the log of a negative number. This guy right here is not a possibility. Because if I were to take you and plug you into literally any one of these, you won't work, you won't work, you won't work, you won't work. However, if I take 64 over 3, which is 21.3 repeating, I could plug that into 3 and it would stay positive. Plug it in here and it will stay positive. Plug it in here, plug it in here. It will all work for all of them. It'll work for all of them. So you are a solution, whereas that 0 was not. So keep in mind, you're going to have answers that don't work. But that, boys and girls, concludes free response question number 3. One more to go and we're done this Unit 2 practice test. Let's go to the beach. Nicki Minaj. We're at the last free response question. The amount of bacteria in thousands found on the beach has been steadily declining. Well, thank goodness for that. Scientists want to create a regression model to show the number of bacteria as a function of years. So 1, 2, 3, some bacteria in thousands, whatever that means. Lots of bacteria, less bacteria, good. What's a logarithmic regression equation that could model this situation? Well, that's going to appear as ln reg in our TI-84 plus. So what we're going to do is we're going to go off to the side. Okay, we're going to type all this information. We're going to stat edit, type in all that information, and then we're going to get ourselves an equation and use that equation to help us answer for B and C, because B and C are going to ask us how many years, blah, 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 how much bacteria, blah, blah, blah. And so we're going to do not only coming up with our equation, but we're going to do some reg EQ stuff. So storing the reg EQ. If you know what I mean, you know what I mean. If you don't, just watch the video. Let's do part A. You'll see what I mean. All right, let's get gross and talk about bacteria. We'll go to stat, edit. We're doing a logarithmic regression equation, which is ln reg. So this is the direction that we go in. Type in your numbers like so. Go over here, your bacteria in thousands. We have to keep that in mind. 9.9, 7.8, 6.7. Don't make a typo. So far, I think I'm good. 5.8. All right, now B and C looks like we're going to need to use this equation later. So not only am I going to come up with an equation, I'm going to store that equation in my calculator. So yeah, we're going to go to stat. Yeah, we're going to go to calc. Okay, ln reg is right there at 9, so we can click 9. That is your logarithmic equation, and ln reg pops up. Again, we need to store this, so we're going to go to store reg EQ, vars, go right to y vars, enter, and now that's going to store it in y equals once I hit calculate. And I need to hit calculate so I can answer A, and A is going to be gross. 9.885 plus, well, minus 2.939 ln of x. So let's go off there and write that out. So for part A, I ended up with y equals 9.885 minus 2.939 ln of x. Gorgeous. How many years until there are 2,000 bacteria? Well, 2,000 bacteria will show up as 2. So at some point we're going to hit 2, and I'm going to run to my calculator, go to the y equals thing, plug in 2, and find out where my ln equation and this 2 will intersect, and that'll give me the answer that I need. Alright, so now that we have that equation, part 2 is asking me how many years until there are 2,000 bacteria in a sample on the beach. So we want to find when this equals 2,000 bacteria. Now, that means we use 2. So I'm going to go to y equals and use 2 and plug that in. And hopefully we see everything. Maybe we do, maybe we don't. My eyes are bad. So I'm going to go to window and I'm going to extend my x value to 20. And that should be more than enough to see the intersection take place. So hit graph. There you go. Now what I want to do is I want to find out where those guys intersect. So second, calc, 5 will let me do that. So let's scroll a little bit closer. Enter. Go to the right a bunch of times. Oh, did I not hit enter? I guess I did. Let's try it again. Enter. Now let's do the second one. Go to the right a little bit. Good. Enter. Enter. And we're looking at 14.627 years. 14.627 years. So let's go over and write that out. 14.627 years. Okay. How many bacteria can be found in a sample after 6 years? This actually is a lot friendlier. All we have to do is just go to the table. So let's go to the table and see what happens. Part C is asking us how many bacteria can be found in a sample after 6 years. So this is pretty friendly. So we're just going to go to second table. We could see 6 already. I still have my old guy there. Don't worry about it. We're looking at y sub 1 because that's where our equation lived. Y sub 2 is just us plugging in for 2,000. So don't worry about that. But we get 4.619. which means 4,619. So let's go back and write that out. Now, the number that we got was 4.619, but what that means in this case is 4,619 whatever. Bacterium. All right, so that concludes our Unit 2 practice test. So I hope this is helpful. I hope you enjoyed it. I hope you study your little keisters off and get good grades. And if you do, come back and tell me how great you did, because I care about each and every one of you. All of my subscribers, all 1 million of you. I'm projecting this into the future. All right, guys, thanks for watching. Love you. Bye.